My fabulous chemistry minions, video number 6, the last one, Half-Life. Woohoo! We are almost done. Sorry, I went fast. Definitely going to be able to do predicting the radioactive half-life all the way through fraction remaining, all this other stuff, right? So, are all radioactive nuclides created equal? Yes and no. They will all decay because they're radioactive nuclides using the idea of half-life, but their half-lives will be different. And there's a big old reference table, I think it's N, that tells us what they all are. And therefore, each radioactive isotope has a different length of half-life. Some will actually be in milliseconds ms, others will be in straight years. Some of them in thousands of years, which would be carbon-14. I think it's 5,700 something, right? So this is the idea of half-life. It's impossible for me to predict which element, I'm sorry, I misspoke, which atom of a particular substance will decay next. I don't know this. But on the grand scale, I can very accurately predict when half of them will have decayed. I don't know which ones specifically will decay, but I can accurately predict when half of them will decay. And half is easy. I just divide by 2. So the math is not going to be super, super complex. And then we figure out what a half-life is. So in order to do this, I want you to use a chart. And you can see little table N is over there. I've made it kind of too small. That should be way bigger for us, but I think it'll be bigger when we actually need it. All right, so I want you to be able to draw charts. So I want you to literally draw a chart. And in these charts, here's some what's going to happen. So I'm going to give you what's going to happen in the chart, and then I'm going to show you how to draw the chart and walk you through it. Okay. So one of the headings in the chart is going to be straight up number of half-lives. This will always increase by 1 for each row in the chart. We will always start at 0. That's the other thing you need to know and have memorized. So we'll always start at 0 half-lives. That's like our 0 point, our starting point, and then we'll go through 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, and those numbers are all predetermined. Okay. The known half-life time will be added. So time will actually be another heading on the chart. And if the half-life is 25 days, at 0 half-lives, the time will be 0. And then at 1, it will be 25 days. And then at 2 half-lives, it'll be 50 days. And at 3 half-lives, it'll be 75 days. We'll just add 1 on each time, whatever that number is. Okay. And then the mass. So the mass is going to be, I mean, I should almost have these guys in red for you, that these are going to be the titles. So the mass remaining is going to be there. The mass is going to be there as a title. Each time down the chart, I will divide the mass by 2. So if I start off with 100 grams and I went through a half-life, I will have half of that much left. So obviously 50. And then from 50, it'll go to 25. From 25, it'll go to 12.5. 12.5 will go to 6.25, right? Just keep dividing by 2 each time we go through. That makes sense. And then fraction remaining will also be predetermined each time, because the fraction remaining at time 0 will always be 1. I have all of the sample that I had. And then after I go through a half-life, I'll have half. And then half of a half is a quarter, and half of a quarter is an eighth. And if we were in class together, I would make sure we're good at multiplying fractions in this way, where you do numerator times numerator, 1 times 1 is 1, and then you do 2 times 2 is 4, and then you do 4 times 2 is 8, and then 8 times 2 is 16, and now we can make sure that these are done. And these will never change no matter what, which is nice. Okay, so let's get into the charts itself. So I'm going to draw a little chart. I'm going to have some number of these rows going across, and then the rows going this way is always 4. So some charts I'm going to need more, some charts I'm going to need less. That the varying up and down, there is no vary across, okay, because I need these 4 things already in my charts: number of half-lives, time, mass, and fraction remaining. And now the way these charts work, I want to go through without a problem what will always be a given in these numbers. So remember, we always start at 0 half-lives, so that's always going to start at 0. And I can go ahead and go 1, 2, 3, 4 all the way down. And that is independent of the problem. Okay. Same with time. Time is always going to start out at 0. That is independent of the problem. So these are always going to be there. Mass will always be dependent on the problem. How much of the stuff is depends on the problem itself, or the how many half lives and blah 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 blah. So we're gonna leave that one blank. And then fraction remaining, I can always fill this guy in also if I need to. And you'll learn as we go through these that we don't need to fill in every one of these things every time. We really need to stick to what the problem's asking us to solve and go that route, right? Fraction remaining will always start at 1, and after that it'll be a half, and then a fourth, and an eighth, and then a 16th. So these guys in blue are fixed. Every time I draw a chart, you can add these guys to your chart right away. And this is how the game is going to be played. So now the time, as I go down, I'm going to add on a full half-life amount of time each step of the way, depending on what the problem is, as far as which element I'm using. Which isotope tells me what the half-life is, and as you can see in table N, they vary. So let's do some examples, and it will be done with our last video, and you can get on to lots and lots of practice problems. So the reading comprehension is the most challenging piece here. Where do I start? Where do I finish? Kind of thing. I need to know that from what the problem says without even reading the problem. And I have a pre-made chart that we can start to fill in. For video purposes, I'm just going to go ahead and fill in the first pieces without reading the problem. Because again, these are fixed things. And I might not need to go all the way. We might find that when we read this, we only go through 2 half-lives, and I didn't need to go to the 3. But I just want to show you in the first few times through that, these are fixed numbers in our chart. So now it says a radioactive element, don't know what it is, has a half-life of 2 days. It says what fraction would remain unchanged after 6 days? Okay, so the problem is giving me days and days, which is times elapsed. So I'm just going to go ahead and start filling in this times elapsed based on what I know until I get to 6, and then I get to stop. Okay, and they're going to help me. So it doesn't say anything about mass, so I'm not going to fill in anything about the mass, right? She just says what fraction remaining. So if one half-life is 2 days, so under one half-life, I want to put in 2 days. And all I'm looking for is what fraction is remaining after 6 days. So I'm going to start at 2 days. One half-life is 2 days. The next half-life would be 2 more days, which would be 4. The next half-life would be 2 more days, which is 6. Now I get to stop. I started at the 2 days, got to my 6, so I know now that 1/8 would be the fraction remaining after 6 days, because notice they're in the same line. That's how these charts work. The problems now can go forwards, backwards. There's going to be a mass that I'm left with, and I got to recalculate how much I started with, or I can have mass that I start with and do half each time all the way down. So the problems can take on all different kinds of forms. Okay, so I just want you to be aware of that. All right, next one. Again, I'm going to fill in my the things I already know, just to get used to that these guys in blue are fixtures. And then I'm going to go right to the problem. A radioactive element has a mass of 20 grams after 3 half-lives have passed. What was the original mass? So I'm going to go to where 3 half-lives was, and I'm going to put in 20 grams because that's what it tells me. It says I have 20 grams left after 3 half-lives have passed. What is the original mass of the sample? So now I'm just going to work backwards. Well, if I just went through a half-life and I got 20 grams left, the opposite of divide by 2 is multiply by 2. So I must have had 40 grams if I had half of it to go to 20. So now I keep going up and I keep doubling as I go up. I'm going to multiply or divide by 2 as I go down in this column. I'm going to multiply by 2 as I go back up. So if I finished with 40 grams, I must have obviously had 80. And if I have 80 grams, I must have obviously started with 160, and there's my answer. Notice in this case, the problem doesn't say anything about time, so I didn't have to fill in anything about time. Hope you're getting a good feel for this, and there's lots of practice. Okay, so let's fill in our knowns right quick. We're getting used to this. Radioactive element has a half-life of 10 years. How many total years have passed after the sample is decayed to 1/4? Well, that's what I'm looking for, reading comp, right? And so 1/4, I'm just going to see how I did this. So I'm just going to fill in the 10 years until I get to the 1/4 line. I don't have to go to 3. So if the half-life is 10 years, after one half-life, 10 years have elapsed, 2 half-lives, 20 years, add 10 more. I could go to the 30, but I don't need to because now look, I've got to the to the 1/4. And literally now the answer is 20. Pretty simple. Hope this reason and logic is starting to sink in a little bit about how to use these particular charts. A radioactive element has a half-life of 5 years. How many half-lives have passed after the sample has decayed to 1/8 of its original? So how many half-lives is what I'm looking for? 1/8. Well, dude, so just go to 1/8. Boom. How many half-lives? These things are already filled out. No matter what the half-life is, 5 years, 10 years, 50 years, it will always be 3 half-lives to have 1/8 fraction remaining. So it doesn't even matter what the half-life is here. I don't need to fill in anything at all. Just the knowns give me the answer to this particular problem. I love region and logic. Oh, and with that, that's the unit. So lots of practice. We'll do these again in class together, and then lots of practice. Check your work and make sure you got the hang of this. With that, see ya.